purpose of this video lesson is to talk about transformation of functions, specifically the reciprocal transformation. Common transformations are taking graphs and shifting them left or right, up or down. We can also vertically stretch or compress a graph. We could also do reflections on graphs. Those are common transformations, but another transformation that the people at IB seem to feel are important are reciprocal transformations. That's especially true when you look at your trigonometry. Every function in trig has a reciprocal function, and if we knew how reciprocals behave, then if I know the graph of a cosine, then I'll also know the graph of its secant, because it'll be just the reciprocal of the cosine. So starting with some generic random function that I put together here, I want to look at, on a point by point, what are some points whose reciprocals I know for sure. So the first thing I'm going to do is examine the places where the function equals 1. So there's one place here, and there's another place right about here where the function equals 1. And, oops, that's 2. This is 1 right here. And we have another one over here. So here's what I know about reciprocals. The reciprocal of 1 is 1. So if this is a graph of g of x, then the graph of 1 over g of x must go through all three of these points here. Now the same thing's true for negative 1. When y is negative 1, the reciprocal of negative 1 is also negative 1. So that gives us points here, here, and here. So now I know 6 points that are going to be also in the graph of the reciprocal of g of x. If this is g of x, my reciprocal will go through all 6 of these points. Now, other ones that are going to be key for helping me get this graph drawn are here. This point is somewhere where y equals 5. So when we look at y equals 5, and I was to take its reciprocal, I would learn that the reciprocal is going to be 1/5, which is 0.2, which is going to be relatively close to the x-axis, right about there. So this is 5, this is 1/5, that's the reciprocal. Here, I can see that the negative 2, or close to negative 2, is the lowest value in the neighborhood. So this number is going to be near negative 1/2, as far as the reciprocal is concerned. Now the last thing about reciprocals that we should know is whenever we have 0 in a function, like 3 x-intercepts here, whenever the y value equals 0, we can understand that the reciprocal of 0 is 1 over 0, and we know 1 over 0 is undefined. So there's not going to be a point on the reciprocal graph for any of these x-intercepts. So how will the graph behave instead? Well, what I'd like to do is point out that as we approach 0 from here, follow the arrow, if this x is 1/2, then its reciprocal is going to be 2. If this x is 1/4, then its reciprocal will be 4. And if x is 1/10, then the reciprocal will be 10. And if x, or y rather, is 1/1,000,000th, then its reciprocal would be 1,000,000,000. In other words, the closer my y values get to being a 0, the more rapidly those y values increase when reciprocated. So the reciprocal of 1 is 1, the reciprocal of 1/2 is 2, the reciprocal of 1/10 is 10. So you can see how that goes. What that means is the function will be approaching infinity as our original function, the reciprocal function will approach infinity as our original function approaches 0. So in other words, I know that there are going to be 3 vertical asymptotes in my graph. Just have to draw them. Now, take all of this given information. For example, I know that there's a point, or 6 points that I knew right out of the bat, plus I have the lowest point, which is the reciprocal of the highest point, another high point, which is the reciprocal of the low point, and if I take all of this information together, I should be able to make a pretty decent graph. So I start here, and I have to head over to this point, and then go up to infinity, and I could start over here and go to this point, and then also up to infinity. Usually when we go take the reciprocal of negative numbers, usually, not all the time, not usually, take the reciprocal of negative numbers, we always get negative results. So whereas here, when I take reciprocals that get close to 0, it goes up to positive infinity. As these y values get close to 0, they're going to go down to negative infinity. So my graph is going to go back from the asymptote through the point where y was negative 1, and then back through the other negative 1, and down again. And then finally, for the other branches, we can see the graph is going to, as this graph goes up and up and up, the reciprocal will get closer and closer to 0, and vice versa. So I should expect a graph that's going to look like this over on that branch, And over here we have a negative 1, so that reciprocates to itself. Negative small numbers reciprocate to negative large numbers, and negative large numbers reciprocate to negative small ones. So now I can see I have a new graph which looks like it's got a bunch of vertical asymptotes and a bunch of these little curvy shapes happening over here. So with all of that information in place, I can actually check to see if I'm right simply by clicking on the graph of the reciprocal. As you can see, it's got all these weird branches, and if you compare that to my work, well, it's kind of hard to see, but you can see those green lines there, and this is the computer's version. So I was pretty close. Feel good. We can do the same thing here. This is an interesting graph. It's got a bunch of weird stuff happening, but if I just take that analysis one step at a time, I should be able to make a nice little reciprocal thingy. So first of all, I find the easiest point is the x-intercept. The x-intercept becomes an asymptote when reciprocated. So here, nice vertical asymptote. Now, I notice that there's an asymptote here when x equals -2. If my function was asymptotic at -2, then its reciprocal is going to be 0. So I have an x-intercept guaranteed. Also, let's find our 1s. There's a 1 right here. So the graph of the reciprocal will go through that point. Here's a -1 right here, so the graph of the reciprocal must go through this point as well. Furthermore, as these get larger, the reciprocals gets closer to 0, and as these get smaller, the reciprocals are going to get larger. So let's take all of this. Oh, I missed a -1 over here. We'll take that -1 as well and reciprocate it. So my graph of the reciprocal must go through the x-axis here, must go through 1, 2, 3 different points here, and be asymptotic when x was around between 1 and 2. So that's going to produce a graph that's going to look something like this, I'm guessing. All the way up there, and down like this. Oops, I can move that over a little bit. There. Once again, I know it's going to be asymptotic this way because as these become large negative numbers, the reciprocals become small, and as these become small negative numbers, the reciprocals become large. So I'm going to see a funky little curve going this way, and then another curve going that way. Let's check it, and click on the reciprocal. And sure enough, that appears to be what I got. Again, we can compare it with mine against the correct graph. If a button will push, there we go. And I feel pretty good about that. I feel really good about that. All right, so right now what you can do is actually just pause the screen if you want to and try to imagine what the reciprocal of this is going to be while you're trying. Well, you already paused it right now, or you're not pausing and you're waiting for me to move on. So I'll do that. Here's what I know. There's a point here, here, and here, because this is a cosine graph. We're going to have 1, -1, 1. We're also going to have asymptotes at all the zeros, here, here, oops, it's hard to draw, and here, and I also have when x equals or y equals 1/2, its reciprocal is going to be 2. So I do know I've got a nice extra point right there. Here, there was a 1/2, so I'm just going to go over here for a reciprocal of 2. Same thing over here. And here. So, all that in mind, I should be able to get a graph of the reciprocal of the cosine, which you may or may not recall is the cosecant, or sorry, the secant. And now that I know what the reciprocal will look like, I want to see how close I am. I'm going to go onto the computer and reciprocate. And sure enough, I get a bunch of horseshoes. Feel really good about that as well. So as you can see, quick little summary, if you want to find the reciprocal graph of a function, identify all the x-intercepts of the given function, those will become vertical asymptotes. Identify any asymptotes of the given function, those will become zeros. Identify any 1s or -1s, and those will stay put in the reciprocal. So feel free to study this on your own. Take a Desmos graph anything you want, and then just graph 1 over that function, and you should be able to predict what should happen before it happens. So thanks for watching. Have a good day.